cloud computing. Before I go into cloud computing, what is cloud? Cloud is basically space on the web. That's what we normally say. So when you say cloud computing, remember, whatever resources you get come from the net, right? Now, the whole scenario of cloud computing. The reason why the concept of cloud computing came into the picture was, one is with increasing need of information on time, then people starting to use more and more mobile gadgets, and then the power of internet, right? So with the coming of these mobile devices, slowly the requirement for accessing information from wherever you are started popping up. People wanted to get information at any point of time, not necessarily when they are in the office, right? The limitation earlier was your data and information was stored on the machine which was there in your office. So after office hours, getting this data was literally impossible. With the coming of laptops, what happened was you could carry the laptop from office to home. So it was there. But again, the problem is you couldn't carry your lap everywhere. Mobile phones became more powerful. Mobile phones became a very important device as far as accessing the net was concerned. Many of the tasks that we do today, we do with the help of mobile phones. And people wanted, or rather people started thinking of ways and means in which you could provide the necessary information through the mobile phones. Now for this, the only solution was, now remember, mobile phones could not have that much of storage as of a laptop or a desktop. So you needed to develop some other mechanism by which you could, these devices could access information from one common place. So if you're using a laptop, you must be able to access it. If you're using an office machine, you must be able to access it. If you're traveling and if you're on a what you call tab or a mobile phone, you need to access it if required. So basically, you should be able to access information from wherever you are. Now, this is possible only if you store data in none of these devices and somewhere else, which could be accessed, where that location could be accessed from any of these devices. So that means I should be able to access it from my desktop. I should be able to access it from my laptop. I should be able to access it from my mobile phone or tab, wherever it is. And that too from any network, wherever I am in the world today. So then people started thinking about, why not store data on the net? Provide storage space on the web. And then use web as a common access area. So everything that you wanted was stored on the web. And then since web is accessible through internet from anywhere, it became easy for people to access this data, which is stored on the web through the mobile phone, through the laptop, through the desktop, etc., etc., etc. So literally your connectivity became more important, not the device. Are you connected or not? If you are connected, then accessing information was no longer difficult. Now this requirement and the arrangement altogether evolved as cloud computing. So as the diagram shows here, you can see you have documents, your finance details, your spreadsheets, database collaboration, your trainings being handled, contacts, email, calendar, presentation, storage, etc., etc., which is all there on the central cloud, what you call, or the net, wherever it is. And you use tablets, smartphones, laptops, desktops, etc. to get connected to the cloud. Only thing is security has to be taken care of. You need secure connections so that nobody else can manipulate your data or meddle with your data. So that's why they say having secure access to all your application and data from any network service. So just remember the basic idea behind having the cloud concept is the capability to retrieve or store data from one common place and retrieve it from one common place, from wherever you are. That means you are not tied physically to any location. That was called cloud computing. Now, what is the advantage of, or rather characteristics of cloud computing? Not advantages, properties of cloud computing. One is the elasticity and scalability. See, when you are storing information on the desktop, the biggest disadvantage you have is when the hard disk space slowly, get exhausted, then you need to get a new hard disk because there is a limit for everything there. But on a cloud platform, storage is literally unlimited because remember, you are storing on big servers and you can always keep expanding there itself. And again, tomorrow, if you are allocated 5 GB of space and you have exhausted all that, you need another 5 GB, you don't have to buy a hard disk. You just need to subscribe to another 5 GB. You may have to pay for it depending on how you use it. That's all. So the moment you subscribe to it, additional 5 GB is available to you. And you don't have to be bothered about where it is stored. You just have to be bothered about the fact that it is being stored safely. That's all. Right? So there is elasticity and there is scalability also. You can increase the capacity to depending on your requirement without bothering about the maintenance, without bothering about the additional hardware cost, etc., etc. You just need to pay as you use it. That's all. That is the next point, which is pay per use. You're using Word for 15 minutes today, you pay only for that time. Using certain software for a certain period of time, pay only for the time you are using it. You don't have to be bothered about buying it. Now tomorrow, if a new version comes in, you don't have to be bothered about buying a new version. When you go to the cloud platform, you select the new version. That's all. You're going to pay almost the same. You're going to use 1 TB of space. You pay only for 1 TB of space. You're going to use only 500 MB of space. Pay only for 500 MB of space. So cost effectiveness also is a very important characteristic of cloud computing because you're paying based on the pay-per-use concept. On demand. Only if you require, you need to buy it. Otherwise, don't. Whenever you want, you get it. See, on a machine at home, you need to install the software. You need to buy the software, install it. And after that, you don't need it. What do you do with that? You have lost your money. That's all. Suppose there is a software which you purchase for a specific purpose. Paid say 20,000 out of your pocket and purchased it. And then later on you realize that is not up to the mark. What do you do with the software? You cannot sell it. Nobody is going to buy second-hand software. It doesn't have any value. But if it is through a cloud model, you're just going to use it for that much point of time and you are going to pay it for that much point of time. Whenever you are in demand, that particular product or service is available to you online. So it is an on-demand platform. Resiliency, dependency is very high. There are highly technically qualified people and technically capable, enabled companies maintaining this infrastructure for you. So literally it is fail-proof. You don't have to fear about the data failure. It's all safe on the cloud. That is the kind of infrastructure they maintain. Then multi-tenancy. Multiple people from multi-locations can access this because it's on the cloud. Not necessary that So otherwise, if it is an office-based system, you had to have a network connecting all these PCs with one another, and you had to set permissions between these machines to help people access each other's data. But if it is on the cloud, you just need to set permissions, that's all. Like today we do on Google Drive, we put a file there and pass on the link to others. So everybody can access it from one single location. I don't have to necessarily send you copies through the mail. So multi-tenancy is possible. Workload movement. When it is on the cloud, the workload is also on the cloud. It is not limited to one physical space. You can carry it anywhere. Literally, you are not carrying it. Wherever you go, wherever there is net connectivity, it is available to you. So these are the characteristics of cloud computing. One is elasticity and scalability. Then there comes the concept of pay-per-use. Then you have this on-demand accessibility to resources. Whenever you need it, you can access it. Resiliency, the dependency, reliability, etc. is very high. Multi-tenancy, multiple people can access it. Then finally, workload movement. The work actually load moves with you wherever you are. Advantages. One is achieve economies of scale. The more infrastructure you have, literally, the more better it is for you to go to the cloud platform, because the amount of cost or amount of money you spend on the cloud platform gets more and more justified when your requirement is larger and larger. Say if you are going to use only 4 or 5 machines, replacing them with a cloud platform might not justify that much. But imagine instead of 10 machines, you are using the cloud, or 100 machines, you are using the cloud. The cost is phenomenal. Cost benefit is phenomenal in the process. And remember, whenever you procure hardware, maintenance cost, environmental cost, etc., so much of cost comes in, which can be definitely reduced. That's the next line. That is again, reduce spending of technology infrastructure. When you buy a server, you need air-conditioned rooms, a good environment for that. You need protection security systems. You need stable power supplies, and so on and so forth. So everything that is required to make that infrastructure work is required. All that cost can be reduced. Then globalize your workforce. When you use cloud, as I told you earlier, people can access it from any part of the world. So your workforce need not be necessarily positioned at one single place. They can be spread across. Streamline the business process. Because everybody is accessing the same information, that itself makes your functioning efficient. Communicating becomes easier. You can streamline your activities very efficiently and effectively. Reduce capital cost. Naturally, reduction in infrastructure will help you to reduce your capital cost. Pervasive accessibility. You can access any quantity of data repeatedly from anywhere, anytime. Monitor projects more effectively because they are all stored in one location. So anybody can access it and the project manager can keep monitoring the activities there. Less personal level training is required because it's all in the cloud. It is there. Help is available online. Minimize maintenance and license charges. As I told you earlier, software, one license per machine is normally how we used to use it once upon a time. But today with the coming of cloud, it is available on the cloud. So you need not bother about license itself. You just need to pay for using that software for so much period of time. That's it. Then improved flexibility. Overall, the work environment becomes more and more flexible. Now today itself, you see, because so much of things we are doing today is because of the concept of work from home, online classrooms, etc. is all possible because of cloud resources. Otherwise, this is going to be very, very difficult. Now, what are the disadvantages? One is loss of internet connections bring the work to a halt. Yes, definitely. Connectivity becomes more and more important. Very critical. You know, over a period of time, how important connectivity has become. 6-7 years down the, I wouldn't say 15 years down the line, net connectivity was not a very big issue. Of course, people were using net, But even if it has gone for some amount of time, it is not so critical. But that is not the scenario today. Today, you cannot think of a situation of a few minutes or even sometimes seconds where you are not connected. Then security becomes very complex. Maintenance of security becomes very critical. So that is a disadvantage. Then comes the issue of ownership. Now, when data is stored on a cloud, who is actually the owner of the data? It is with somebody else, but you are the owner. Now, whom will you held responsible if something goes wrong? Whom will you hold responsible if something goes wrong? If the data is lost, I am the owner, but can I be blamed because it was not with me? So the blame should be put on the service provider. Now, will he take the responsibility? That is another question. So these kind of issues are there. Then dependency of vendors brings restrictions. You are using somebody's machine, somebody's server. So when you keep data with them, then you have your own limitations. Say, for example, an organization is using a cloud-based software. Now all the data is stored in the cloud. The application is running on the cloud. Now the question is, what happens if the data is lost? Or does the organization have the power to back up the data? If it doesn't have power to back up the data, then it is in trouble because that is a restriction. Will the service provider take care of the data like the organization is going to take care of its own data? It's another challenge in itself. Then interoperability could be an issue when applications reside on different machines on the cloud. Now, if there are different applications running on different machines on the cloud, if you by chance want to mix them up and use it, that could be a challenge because that may not be possible. Because again, remember, it is under somebody else's control. You have your own limitations. So those are the disadvantages of cloud computing. Now, cloud deployment models. What are the different ways in which cloud is deployed? Primarily, you have two types. One is private and one is public. Then the third one, which is a mix of both private and public, which is called the hybrid. Right? Now, we shall see each type of cloud. Now, the environment is something like this. You have private internal cloud, public external cloud, and the cloud as such, which is basically the public cloud. And in some cases, you might be using a combination of the private and public. That is why this combination of these two is called a hybrid cloud. Private clouds. What are the characteristics of private clouds? One is it is secure because it is under your control. It's private cloud. You have all the power to do whatever you want with the cloud. So naturally, you can implement a better security on the private cloud. You can do a central control on that, and then weak service level agreement. See, all these are maintained by service level agreement. You call SLAs. So when it is your own, agreements don't matter much. Agreements matter only when it's a third party getting involved. So in this case, you can manage with a very weak service level agreement. So one is security is an advantage. Central control is an advantage. Sorry, characteristic, not advantage. It is more secure than probably the other networks, other models. Then you have a possibility of central control. And then finally, weak service level agreements. Because basically the agreement will be between your IT department and the users, internal to the organization. Advantages. It improves average server utilization, allows user of low-cost servers and hardware while providing higher efficiencies, thus reducing the cost of a greater number of servers would otherwise entail. Since it's a private cloud, information can be shared by everybody, resources can be shared by everybody, thereby to a great extent reducing your internal investment, right? Which would otherwise have been more if you're going to have servers for different purposes. Then it provides a high level of security and privacy to the user, again, because it is a primary characteristic of a private cloud. It's under your control. It is small and controlled and maintained by the organization. So that itself is an advantage. Disadvantage means your investment will be high because you have to maintain this infrastructure because it is your own private cloud. That is a disadvantage. Compared to private clouds, public clouds, highly scalable. Scalable means when you want more capacity, you should be able to get it. In private cloud, because you are maintaining the infrastructure, you have to do investment. Scalability is not easy. You need to buy infrastructure or something from outside and then use it. But on a public interface, infrastructure is already available. It is only whether you want to increase your usage or not. That's all. It's already there. You can always increase your capacity by requesting for more resources. Security is kind of partial because it is a public platform and you are working on a public platform. Your data is on a public platform. So you cannot guarantee 100% security because actually the resources are stored by somebody else. They are managing it. So that is why we say partially. Service level agreements should be very stringent in this case because there is a third party, an outsider involved. Agreements should be put in proper place. Otherwise, in case of issues, then managing those issues will be very critical. Then complex management. Definitely, all these resources are there. The cloud is outside your control. Then managing it properly will be a challenge for the public cloud. So these are the characteristics of a public cloud. Highly scalable. You can increase your capacity as and when you want it. Partially secure, not completely secure. Stringent service level agreements and complex management. Advantages is highly scalable and reliable and provides the advantage of private and public cloud. So having a public cloud, you can make it almost like your private cloud with the advantages of public cloud. And scalability definitely is an advantage. Without investment, you can increase the cost. Increase the capacity just by paying more. You don't have to bother about the maintenance. You don't have to bother about buying it, etc., etc. Then, since it's already a public cloud, they will have their own security measures. So therefore, you can have a better security than a public cloud. Sorry, better security than private cloud, not public cloud. Disadvantages, security features not as good as private cloud because private is completely under your control. Right? So that way you get better security in private cloud. But in a private cloud, the amount of money we spend on security might be comparatively less. So that way, here, public cloud security may be better than what you have in the, but there is a limit to how you can implement it. That is the problem. That is the issue. Hybrid cloud is a mix of private and public cloud. You have a private cloud and you have a public cloud, and there is one area which is a mix of both private and public. Characteristic is again highly scalable because you have the public cloud background. It is affordable, cheaper than private cloud, less secure. Maybe because though it shows it's partially private, but it doesn't give you all the advantages of private cloud, security, private cloud. Highly available, reliable because it's a mix of both. Then, of course, because third parties are involved, it is better to have stringent service level agreements. Advantages are deployment at very affordable cost. As I told you earlier, and I've been telling you earlier, cloud is a resource available on the net. You need to pay only for what you use. So definitely affordable cost, highly scalable and reliable. You can keep on increasing the capacity as you require. Then infrastructure maintenance not required. If at all you require, it is only for the private part of it. The other is taken care of by the external part. Service level agreements are in place, so that way you are slightly safe. Then no limit to the number of users. Now that is one advantage. In private cloud, there is always a limit to the number of users. In public and hybrid, since there is a public platform available, there is no limit to the number of users. Disadvantage, like we told in the public cloud, trust and ownership is definitely a problem. One thing is you have to trust your vendor, and then the ownership issues. Who is responsible for what? It's very difficult to clearly define. Now, apart from this, you have got something called the community cloud. Why do you have this? So you have cloud, you have one organization, you have another organization, user 1, 2, 3 are all accessing the cloud. So multiple organizations or multiple groups of people accessing the cloud. Now that is called a community cloud. Now characteristics of this is collaborative and distributive maintenance. So community clouds are basically used for collaboration. That means when 3 or 4 team of people want to join hands to do something. So they are collaborative in nature, and actually they are doing it together because work is distributed among various groups. So that is why we say distributive maintenance. They're partially secure because always the public aspect is there, cost effective. Otherwise, maintaining these type of networks would have been very, very, very expensive. Then advantages. It allows establishing a low-cost private cloud. It allows collaborative work on the cloud. It allows sharing of responsibilities among the organizations. It has better security than the public cloud. Now, one thing is, first line is clear. It allows establishing a low-cost private cloud. Because ultimately what happens is, when it is a community cloud, it is almost like a private cloud on a public platform. So you're using a public platform to build a kind of private cloud, where the infrastructure is on the public platform, resources are on the public platform, but you design the access in such a way that they can be accessed only by your respective people or people who belong to that particular community. Collaborative work is possible because, as you know, it is actually teams of people working together. Now, because there are different teams, you can call them organizations also. Responsibility can be shared between different teams. And finally, security can be managed better than a public cloud because there is a specific set of people doing these specific tasks. So you can limit those freedom to those set of groups of people, thereby having a better. In public, it's not possible. Public is more open. It can be accessed by anybody. So there is a limit to the amount of controls you can put there. But in a community cloud, you can definitely put restrictions based on the community of people handling that particular platform. Disadvantage. Autonomy is lost and security becomes a challenge. Because there are so many group of people involved in this, you are losing your autonomy. That is, a complete power to manage all this is lost as far as the user is concerned. Now, there is something called the 3-4-5 rule of cloud computing. This is not there in your book, but I felt it is important, so I included it here. 3-4-5 basically means 3 services provided by the cloud, 4 deployment models of the cloud, and 5 characteristics or features of the cloud. So this diagram that way is very important. If you look at it, you can remember about, you can probably answer most of the questions related to cloud model. Now, what are the 3 services provided by the cloud? One is IaaS, infrastructure as a service. We'll see that in more detail later on. PaaS, which is platform as a service, and SaaS, which is software as a service. Now, these are the 3 types of services provided by a cloud model: infrastructure as a service, platform as a service, and software as a service. Now, using these 3 types of services, there are 4 deployment models. One is private cloud, community cloud, public cloud, hybrid cloud. Right now, private cloud can cater, ask for only infrastructure as a service and a hybrid cloud, both. Platform as a service is there for community cloud and public cloud, whereas software as a service can be utilized by all of these people. Now, this doesn't come here because private means it is completely owned by one group. So only infrastructure as a service can be used by private cloud. You cannot use platform or software as a service. Now, what are the characteristics? Whatever it is, on-demand self-service. You can decide when you want what and use it. Broad network access. Resource pooling. You're pooling various resources for utilization. Rapid elasticity. Whenever you want, you can increase it. Measured service. Whatever service you are using is measured, and you are paying according to that measured usage only. So please try to remember this particular slide, which is 3-4-5 rule. 3 services provided, 4 deployment models, 5 characteristics. 3 services provided is IaaS, PaaS, and SaaS. Private cloud, community cloud, public cloud, and hybrid cloud. And then on-demand self-service characteristics, broadband access, broad network access, resource pooling, rapid elasticity, and it's always a measured service. Now, cloud computing service model. As I told you in the previous slide, infrastructure as a service, platform as a service, software as a service. Now, characteristic is web-based access to resources. Whenever you say cloud, remember the access is using the web. Centralized management. For infrastructure, now we are talking about infrastructure as a service. Now, infrastructure as a service basically means infrastructure is provided as a service to you. Software, etc. is your responsibility. That means you get only the hardware part of it and the network part of it, or the storage part of it, or probably a database part of it. The contents, everything has to be managed by you. Right? Okay. So one characteristic is web-based access to resources, centralized management, because infrastructure is given to you from one single point. So definitely that is a possibility of centralized management. Elasticity and dynamic scaling. Whenever you want to increase the hardware capacity, you can do that by selecting options. You're sharing the infrastructure with someone else. That means the infrastructure that is provided to you is not 100% yours. You're sharing some part of it might be used by somebody else. Say, for example, that system contains a i5 processor or 4 i5 processors with a 5 TB hard disk, and you don't require all that. So maybe you're given only one i5 processor of that, and then probably 1 TB space is allocated to you. Remaining is shared by somebody else. And metered service. Whenever you're using the resources, a meter starts running, and you will be charged according to that particular meter. Now, instances of infrastructure as a service. Therein, you can give network as a service, storage as a service, database as a service, backend work as a service, desktop as a service. So that means even a desktop can be accessed using a client. Now, why do you require a desktop as a client? Now, suppose you have got a tab. You need the power of a desktop. You can avail it through the cloud. That means literally your tab gives you the power of a desktop. Where does the power come from? It comes from the infrastructure as a service provided by some other vendor. Right? Okay. Platform as a service. A typical platform as a service provider may provide programming languages, application frameworks, databases, and testing tools apart from some build tools, deployment tools, and software load balancers as services in some cases. So platform as a service, simply put, I will tell you, is infrastructure as a service plus operating system also will be given to you, plus some language tools. Say, for example, you need a Java compiler, you need a Visual Studio working environment, all that is given to you. So a working platform is given to you. Remember that. A working platform is given to you when you are provided with platform as a service. Then comes software as a service. So if you want, say, for example, Tally, you're not going to buy Tally, you want to use it as a service. So Tally is given to you. You can use it on rent. You can create your own company. You can set up your accounts, do everything that you would normally do. But only thing is you're sharing it with somebody. And you're not going to buy the software, or you're not going to buy the license. You're just going to pay depending on how much time you're using that particular software. So apart from that, you have testing as a service. You want to test your software. You need tools for that. That is available to you. API as a service, application program interface, that gives you various functionalities. Since you are non-technical people, you don't have to go to all details. Just try to understand it by heart. So API is as a service, as application programming interfaces are provided to you as a service. Then email as a service. That means if you want to host your own email servers, right, for your office, record management, migration, integration services, etc. You want to have your own spam blocking facility. You want to have your own malware protection. So all these services are provided when you ask for software as a service. Next slide will give you a better idea. Okay, other cloud service models are communication as a service, data as a service, security as a service, identity as a service. So these are some examples of other cloud service models. Communication, voice over IP, etc., instant messaging, collaboration. Then data as a service. You can get data from other companies, right? Or you want somebody to encrypt your data, that is a service. You want some certification of data, that is a service that is given by somebody, right? Security as a service. When your people access cloud services, you want somebody to monitor those services when people are accessing data and information on your this thing. Say, for example, you want to monitor all the mails that are sent from your official mail ID. You don't have the technical know-how to do all that. So you can get somebody's help for that, to make sure that your employees are not exchanging some valuable information through the mails. So there are people who will provide you security as a service. Similarly, identifying users, that also, if you don't have infrastructure to validate all these details, then you can get the help of somebody else to do all the necessary validations required to make sure that a proper identity is maintained for each user in the organization. Now, just to give you an idea about IT infrastructure and cloud platform as software as a service, platform as a service, and infrastructure as a service. Traditional IT infrastructure, if you look at it, you manage everything, right from application, data, runtime, middleware, operating system, virtualization, servers, storage, networking. That means all aspects of IT infrastructure is managed by us. But if you are going to take infrastructure as a service, you are provided with networking, you are provided with storage, you are provided with servers, you are provided with virtualization, you are provided with operations, which is partially delivered as a service and partially you manage. Everything above that is managed by you: middleware, runtime, data, applications. So all the software aspects are managed by you. All the hardware aspects other than the operating systems are managed by the service provider. Now that is called infrastructure as a service. So once you have this, you can run your applications, you can store your data, you can do whatever you want, right? When platform is given as a service, up to runtime is given as a service by the service provider. So along with hardware, the basic infrastructure required to run the software is given as service. That is given as a platform to you. You need to manage only your application and your data. That's all, nothing else. Right? When you take software as a service, everything is given as a service to you, right from networking to applications. Everything is provided as a service. You just need to operate it. That's all. That means application programs are given to you, the data is managed by them, everything is done by them. So this is actually the best approach for very small organizations who don't want to maintain their own infrastructure, who don't want to spend money on software. And the advantage for them is you are using all these services, but the amount of money probably you would pay to these service providers on the long run would be much cheaper than the cost or the investment that you would have to do on basic on the what do you call infrastructure, right? If you had to maintain your own infrastructure, if you had to maintain your own what you call hardware, the cooling capability, the hardware capability, the service engineers, the details provided, etc., etc. All these aspects have to be taken care of by you. So the cost incurring on you for that, if you look at it, will definitely be much more than what you have to pay for all this if you take software as a service. Next comes mobile computing. The concept is very simple. Behind the scene, everything happening is based on the infrastructure. So you have a radio link, you have a mobile device which help you to do all that. Rest, everything is the same. You have a fixed participant, you have telephone links, switching center, conversion center, and the whole IT infrastructure behind doing all the work for you. That's all. Now, components of mobile computing, if you take mobile communication, mobile hardware, mobile software. So you need infrastructure for mobile communication. You require the hardware required for mobile, providing mobility, and then also the software which will support all these mobile activities. Now, benefits of mobile computing. What are the benefits of mobile computing? One thing is it helps mobile workforce, right? That means people can carry the work around. That is the best advantage. And as far as your customers are concerned, they can always interact with the company wherever they are, depending on the urgency at any point of time. So facilitates corporate access, facilitate access to corporate resources anytime, anywhere, right? Then it enables to improve management effectiveness by enhancing information flow. Since there is no physical restriction to data, definitely you can access it from anywhere at any point of time, and flow of information is happening throughout. So definitely you can manage information flow better. Now, the moment you have information flow better, your decision making is also very huge, very high. Now, limitations of mobile computing. Of course, mobile phones do have a problem with the bandwidth. The amount of data transmission you can do with mobile phone is very, very limited. Security standards, again, changes from device to device. So that is, again, another problem. There are different service providers and different people who manage these equipment. So you cannot control the security on these devices which people are using to access it. Power consumption, okay, you can say power consumption is comparatively less, but you have to keep your devices charged, etc. Then transmission interferences are possible because you are traveling. High power lines or high grade power lines, etc., or other magnetic fields, etc., can affect the transmission of this. Then potential health hazard, the disadvantage of mobile phones or devices which we carry throughout. We keep on saying that too much of radiation can happen, which can have issues to people's health. Then finally, human interface limitations. It's not as convenient as working from a laptop or working from a system. Next is green computing. This is a very small concept. The objective of green computing is to reduce the use of hazardous materials, maximize energy efficiency during product lifetime, and promote the recyclability and biodegradability of defunct products and factory waste. Such practices include the implementation of energy efficient CPUs, servers, and peripherals, as well as reduced resource consumption and proper disposal of electronic waste. Now, we know the biggest challenge faced by this world today is e-waste. right? What do you do with all this? So green computing is basically trying to find out methods by which you can reduce this hazardous materials, reducing power consumption and efficiency of the product lifetime. And also, if possible, wherever possible, recycle these products and probably support biodegradable products also, thereby keeping the environment safe for human beings. The best practices of green computing is develop a sustainable green computing plan. A plan should be there. The organization should have a plan as far as how to go about green computing. How are you going to make your whole infrastructure environment friendly? What plans do you have for recycling the products? Then make environmentally sound purchase decisions. Whatever you buy, think 4 times and confirm that these are all environment friendly. Then reduce paper consumption to the maximum. Paper is one of the stationery which affects the environment also, because paper comes from wood. Finally, conserve energy to the maximum. Try to use energy very efficiently. Okay, I think we'll stop for the day. We'll continue in the